Hello friends, this is Suresh and today we are going to learn about tensors and how can we implement it tensor using Pytorch and we are comparing with the Numpy also. So first I will go through Numpy array and compute gradient with the Numpy and update the update the weight parameters. So, and one by one I will compare with tensors and update the weight using the PyTorch also. Any the machine learning the workflow, we need some data. In supervised learning, so we need data with label. So here in this example we will create a random we create random data and the labels, and same we initialize the random weight with the random values. So any models like generally like we have thousand of images and we create a batch size like 32 batch size, 16 batch size, 64 batch size. So similarly I will create as an example here. The batch size is 64 and number of hidden is 100 and number of inputs dimension is d in and d out is 10. So for that input example I will create np.random.random n is the number of passes and d in is the number of the inputs. So number of batches 64 and number of input is 1000. If you will print x, so you will get the matrix 64 by 1000 columns. So, similar y also, so we create the y matrix, and then for that learning that we have to update the weight, that weight w1 w2. So initially we have to initialize the weight using randomly. So here I initialize weight randomly, and different machine learning algorithm initialize the weight as per their requirements. So here in this example just 10 that for loop running step 10 steps. So t is the step and we will run for loop in 10 steps. Yep. And then next we are starting the computing. So generally you heard about zg is equal to x dot w plus b. That formula generally, that generalized formula you heard about that for in the machine learning and that algorithms. So here x dot w, that is hypothesis, and h underscore ReLU call, like is the maximum whatever input we are passing. So we are passing h, so that is the ReLU, and y predict, that call that multiplication with whatever output in the second hidden we are getting, that h ReLU, that should be passed in the y prediction. That dot product of w, that is the y predict. And what is loss here? So for particular batch size, loss call like y prediction minus y actual, that call loss. And that gradient compute by the chain rule like compute using the chain rule, gradient underscore w, gradient underscore w2, and gradient underscore w1, that computed, and we are updating the weight. W is minus equal to learning rate multiplied by grade w. Similarly here we are comparing the results in the Numpy. For the initialization generally use np.random. In tensor we will use toss.random. So here similar like np.rand, here toss.rand random function. So both here for same like np.random.array and that pass that whatever parameter we are already defined. Same here we have to pass the parameter. Here they pass one parameter that called device, so that computation will happen on GPU or CPU, that we have to pass the device here. Like I use CPU or GPU, whatever you have to pass here, we have to define the device here also. Same weight parameter also we initialize, and same epoch running here. And that for here for h underscore ReLU, you looked here that call np.maximum and np.dot, that white, and so here you look that formula slightly that syntax will change. So np.mm, that call dot product here. So like call it like dot product here w. So dot w, that call x dot and dot passing the weight parameter. So it will do dot product, and clamp is the maximum, and again that dot means again like this dot product. So here we are doing the dot product here same, so it will do dot product. So some genetically changed, but all the things are similar. And same the chain, using the chain rule, compute the gradient and update the weight. So difference here, numpy with pytorch, the major difference, like numpy work on the CPU and it's a computationally like unable to handle the large workload, and pytorch like this torch, it will handle the loads and we can run on the GPU also. So it's computationally uh, as a platform wise, like we can use on the GPU and CPU core. So this is basic about the tensor. So generally you hear about the tensor, nothing is the like n dimension of array in both cases. So in Pytorch we are calling the tensors, and that call n dimension array. It's all about the Pytorch tension and numpy array in dimension array. Thank you.